Hi everyone, welcome back to Chem Help ASAP. Now in a previous playlist we did Lewis structures for ions. However, we only did monoatomic ions in that video. In this video we are going to see what happens when we have a polyatomic ion. So let's get started. For our first polyatomic ion, let's do a cation. Let's do ammonium. It has a +1 charge. Okay, so let's add up valence electrons. Nitrogen gives me 5. I have 4 hydrogens. They each give me 1. Now the trick with polyatomic ions is you have to take into account the charge on your polyatomic ion. If I have a charge of +1, that means I have lost an electron. So I am going to subtract 1 electron from my total count of valence electrons. So that means I have 8 valence electrons. Okay, I'm going to assume nitrogen is the central atom. So nitrogen has 4 hydrogen atoms around it. I'm going to start by sharing 1 pair of electrons for each. And that is my total. And that's 8 valence electrons. Let's check my octet. Okay, nitrogen is good. That hydrogen is good. So is this one. This one, it looks like all hydrogens are satisfied. So when I rewrite this neater and I use my bonds, I have a single bond between nitrogen and each of the 4 hydrogens. And I also need to specify my charge. Let's do a very common polyatomic anion. Let's do sulfate. Okay, so adding up valence, sulfur gives me 6. I have 4 oxygens. They also give me 6. Now I have to deal with this charge. If I have a charge of -2, it means I have gained 2 electrons. So I am going to add 2 electrons to my total valence count, and that is going to give me 32 valence electrons. Okay, I am assuming sulfur is the central atom here with 4 oxygens around it. I'm going to start by sharing 1 pair between sulfur and each oxygen. That's 8. Now let me see how far the 32 valence electrons will take me. So far, so good. Okay, I haven't run out yet. That's 30, that's 32. Okay, let's check octets. Sulfur, yes, 8. This oxygen, okay, that's good. This oxygen, yes, 8. This one, all right, 8, 1 more, and yes, that one also has 8 valence electrons. Okay, we've got a valid Lewis structure. Now let's draw it out a little prettier than this. So sulfur has a single bond to each of the 4 oxygen atoms. Now remember, you must put in the lone pairs. And for sulfate, this means quite a few lone pairs. So make sure you get all of those electrons in there. And of course, this is a charged species, so I will bracket it and put the charge on the outside. Let's move on to another common anion. Let's do nitrate. Okay, when I'm counting up valence, let's see, nitrogen gives me 5. I have 3 oxygens. They each give me 6. My charge here means that I have gained 1 electron. So I have 24 valence electrons. Okay, again, I'm going to put nitrogen in the center. It has 3 oxygens around it. I am going to start with single bonds between all atoms. Okay, so that's 6, 8, 14, 22. Okay, that's 24 electrons. And I can already see that this oxygen only has 6 valence electrons. Its octet is not satisfied. Okay, let me do some modification. Let me erase my circle I did here. Try not to take out the nitrogen. And I'm going to take this lone pair on the nitrogen, erase it, and I am going to make a double bond right here. Okay, so let's check. Let's make sure that we have used 24 valence electrons and we have not created or destroyed electrons. So just double check and make sure, yes, you have used 24 electrons. Okay, let's check octets. This nitrogen, 2, 4, 6, 8, yes, that oxygen is good. That oxygen is good. And this one, 2, 4, 6, 8. Yes, okay, now I have a valid Lewis structure. Let's rewrite this a little prettier. So we've got a single bond here, a single bond here, and a double bond to this oxygen. Now let's put in our lone pairs. Let's see, this one has 3. This oxygen also has 3 lone pairs, and let's not forget our brackets or our charge. Now, hopefully you have skipped ahead of me here and realized that we have resonance structures. I have placed the double bond to the leftmost oxygen, but it does not have to be there. So what if I put the double bond with this oxygen and made these single bonds? Okay, don't forget your lone pairs here. It's not a valid Lewis structure if you don't have all of your lone pairs. Okay, double check. Is that a valid Lewis structure? And you can check and make sure that each atom has a full octet. Yes, they do. That is a valid Lewis structure. However, we actually have one more resonance structure here. We can move that double bond to the far right oxygen as well. Again, I will put in my lone pairs. Don't forget my brackets. I'm kind of squeezing in this charge here against my sulfate. And you can see in the case of nitrate, I actually have 3 resonance structures. When you are doing Lewis structures of a charged species, please make sure you use the brackets and you put the charge in the upper right-hand corner. I know these details seem annoying, but you want to make sure you're communicating clearly to your reader. And I know for many of you, your reader is also the person who is grading your work. So you want to make sure that all of those details are in place. Now, I hope you'll join me for my next video where we are going to start breaking the rules. Thanks so much for watching.